So as I have already discussed, so this cam is a kind of rotating or sometimes reciprocating kind of mechanical element, which basically provides a certain kind of desired rotating, reciprocating, or some oscillating kind of motion to on another element, which is kind of attached with it, and that particular element we call it. Okay. So yesterday we have discussed about how basically a cam and follower work. Okay, what is the need of that particular contact? If the contact is broken between cam and follower, is it going to work? Will the follower get motion from the cam? So the answer is no. Okay, the constant contact has to be there. Okay, so whenever the contact between cam and follower actually it gets void, okay, then basically there is no kind of motion transfer, desired motion transfer to that particular follower. Okay, so that's why constant contact between the cam and the follower is necessary. And in the last class we have discussed about all those, you can say, uh, the things like yes, hello, just wait. Okay, I'm trying to show you. Yeah, to rotate that particular view. Okay. So yes, so is it visible? The figure visible?
Yes, sir.
Okay. So what I have shown here is a yes, it's a radial cave. Okay. There you can see we have shown this is a kind of cam. Okay, and here we are showing a roller follower. Yesterday, whatever we have shown like a pointed one like this. Okay, that was a kind of we call it as knife edge follower. Okay. So now what happens when and this is the center of rotation of this particular cam. That means the cam is rotating about this particular center, and the contact of this particular follower with the cam is there, the constant contact, and we are providing a guide or frame to it. Okay, and what happens? So whenever it is basically rotating, then we have got this particular cam profile or the working surface of the cam, and because of this design, actually, what basically happens? So when constant contact is there, depending on what is the position of that particular contact, whether this is going down like this, okay, whether it is in this upward position or in this side or that side, okay, depending on that, what will happen? So this follower will, as it is in constant contact, it will also move either up or down along with it. Okay, so this is how they are. So this kind of follower cam is known as radial cam. Okay, and here you can see this is the center of rotation of this particular cam, and here this is the follower axis, follower rotation axis. Okay, so the motion of the follower is in this particular direction. Now, in this particular case, actually, this particular type of cam and follower, it has got certain name. Okay, so this is the inline type. As you can see, this particular axis of rotation, it is passing to the center of rotation of that cam. So, if this is the situation, we call it a kind of inline kind of cam and follower. Now, if you think, okay, the follower is somewhere here, and if you draw the axis of rotation, okay, then it will pass to somewhere here. Okay, it will not pass to the center of rotation of that particular cam. Then we call it as a kind of your offset type of cam. Okay, is that clear? So now there is like as you're saying, we are talking about this. If we think of the manufacturing of this cam, okay, then in large scale, if we are thinking of production of cams, then they are done by like punch presses and all. Okay, the punch press we have got die casting and filling methods. Okay, and as we have already discussed, so almost always the cam is the driver one and the forward is the driven member. Okay, and how what kind of motion the forward will get, that will be mostly dependent upon the shape of that particular. We call that as the profile of that particular. And later on in this particular here itself, okay, we'll be discussing about can say how to, for a particular purpose, okay, for getting a particular motion, required motion, okay, and we discussed about designing of that particular game. Okay, so now, so yesterday we have discussed about different classifications of game based on its shape. So there will have things, can be, we can have radial game or disc game, okay, we have cylindrical game, we have like end game, we have wedge and flat game, we have spiral game, conjugate game, etc. etc. And I have told you regarding what is the leaf that we expect on that particular for a particular cabin floor. Okay, so in that case already we have discussed like basically the requirement of eccentricity. If you think of that a kind of circular kind of cam, okay, a circular element you're thinking of using it like a cam. And already we have discussed, if the center of rotation of the cam is exactly at the geometrical center of that particular circle, okay, circular cam, then it is not going to behave like a particular cam, because in that particular case there will not be any leaf that will be given to that particular follower. Okay, so follower will remain stationary in this particular position itself. If this is the follower position, let's consider we have got this particular follower. This is the roller follower. As you can see, one roller is attached at the end point of that particular follower, which is in contact with the cam. So this kind of follower is known as roller follower. So now in that particular case, what will happen if the center of rotation of the cam is somewhere here, exactly at the geometrical center of this particular circular cam, then it is not going to give any kind of motion to that particular follower. Okay, why? Because in that particular case there will not be any motion here. Why? Because this all these distances, this, okay, so this is same only, all are equal. Okay, understood. So that's why the center, if it is a look is something like this, then in that particular case it has to be eccentric. Okay, otherwise it's not going to. If this is eccentric, it will work. How? We have already discussed. So suppose if this is eccentric, then you know about this particular center, it is rotating. So there will be time when it will also have this kind of position. When it is rotating, it will also assume this kind of position. Okay, so this will be one of the another position of that. Okay, this particular cam itself. So in that particular case, previously if the let's consider this is the follower. Okay, so previously if this is the follower, then the follower will go down up to this much. Okay, so this is how we can get that particularly. And similarly here in this particular case we have shown it's possible that the cam might be a reciprocating element also. Okay, so now what is this radial or disc cam? So now in radial cam what basically happens, so the follower it reciprocates or oscillates in a direction which is perpendicular to the cam axis. So now what is this cam axis? So cam axis is nothing but we are talking about cam axis of rotation. Okay, so if we think of this particular, here we have got the shaft, that is the rotation axis will be here, so it is into that particular plane if you consider like that. Okay, and the follower axis is this one. This is the follower axis. Okay, so and actually in that direction into that particular plane or out of this particular plane along, if you think of x axis, x axis, y axis, then here we have got the z axis, either you can consider in this direction or into the plane. So that way we have got the cam angular axis. Okay, cam rotation axis, and this is the, this way we have got this particular follower axis. Okay, so in radial cam what happens, so this this follower is going to, and in this direction follower has got the motion, so it will be in a direction perpendicular to the cam axis. Okay, so there may be so many different situations, so we can have different depending on what is the just like the we have got different shapes of cam. So similarly the followers also we can classify based on its the point of contact. Okay, the can say what kind of contact it is there. Okay, what is the surface that is there in contact with the cam. Okay, what is the shape of that, depending on that particular shape the followers can also be classified. So here in this particular figure, whatever follower that you see, that is a knife edge follower, because this look is, you can see the contact point is, it's kind of as if it is a kind of the knife edge. Okay, so next one, here you can see here it is somewhat different. So here at the end point we have got a roller attached here. Okay, so now in this kind of follower is known as your roller follower. Okay, now here from the look of it, so basically you can see the contact surface is kind of flat here. So this they fall under flat face follower. Similarly, it looks like a kind of mushroom. Okay, this particular case. Okay, so it is spherical face follower, or sometimes this flat face follower and spherical face follower are sometimes integrated. Okay, called as mushroom follower. Okay, so now here you can see once again, like this is the cam, this rotating. Okay, and this is the follower. Okay, and now what happens right now, whenever there is due to this profile, it is we call the working surface of the cam as the profile of the particular cam. And whenever you see, uh, if this is the profile, sorry, let's do that. Let's consider this in this figure set. Okay, so if this is the profile, so you can see in this case from here to here, almost this case. Okay, almost this angle. So here it is a constant radius curve which I listed. Okay, okay. So during that time, what happened when this portion of the cam is rotating and it is coming in contact here? So during that portion, actually, there will not be any movement onto that for on that particular follower, even though this portion of the cam will rotate this particular portion. Okay, so that particular period also has got a name. We call it as a real period. So in that particular case, what happens? Even the cam is rotating, the follower will not get any motion. And that is based on the, you can say, the whatever is the profile that is there, profile of that particular cam. Okay. So similar is the case if you look at this portion also was, if we think as if this is the from this is the center, so from here to here, almost this portion has got, you can say, equal radius. Okay. So I can as if draw a circle here. Okay. So sorry, my figures are very bad. So here I can think of as if we have got a this person is constant radius. Okay, similar is the case. Suppose this person is constant radius curvature. Okay, so during this portion, that means whatever is the position of this particular follower, the follower will remain there. As it is evident from this particular figure, if you look at this particular portion, this bigger portion on that particular dimension. So whenever this particular portion is in contact with the cam, then even though the cam is rotating, the follower remains stationary for that particular time. Okay, and whenever this other portion from here to here the contact is there, so during that portion, actually, gradually the cam is either moving up or down, okay, depending on what is the direction, and for a certain fraction of time, when actually this particular portion of curve, which is once again a constant radius curve, only this to this you can consider, okay, it's a part of the circle, so constant radius curve. So in that particular case, once again, what happens? This portion, right? Same is the case with this much portion. Okay, so in that case, once again, the follower is stationary. Okay, even though cam is moving. So these particular portions are known as period of dual or dual period. Okay, understood? Yes or no? Let me know.
Yes,
Yes,
sir.
Okay, so now that means the complicated motion, we have said that complicated motion, for generating different complicated motion, we use this Cayman follower. One classic example we have given the example of your that opening and closing of different operating the valves. Okay, operating the valves of that eye change. So there, this kind of situation is required, right? We have said that yesterday. So the on inlet valve should open, it should remain open for a certain duration of time, so that proper intake of that particular surge is there, and after that it should remain open for a certain amount of time, so that the two strokes, okay, compression and power stroke, etc., they can occur properly. Okay, and after that the next valve, that is the exhaust valve, should be operated and it should open and should remain open for a certain finite amount of time. So this kind of situation, for getting that kind of situation done, okay, so what we do, we design that particular, we have to design that particular cam properly, and wherever actually we need this kind of dwell, that means the cam is kind of moving, and for that particular period there should not be any motion on that particular, let's consider whatever is the, if we think of the valve, then it will be the valve or whatever is the follower. Okay, so in that particular case, that means so we have to be judicial enough so that we have to encounter, that means that constant radius curvature on that particular cam during that particular time, then only we know that even though cam is rotating, so whatever time it takes for rotating, definitely it is rotating at a certain angular velocity only. Okay, a certain angle is traversed within a certain amount of time, so that means if we have to traverse this particular angle where we are encountering constant radius curvature, so it is going to take some time. Okay, so depending on whatever is the angular velocity, so it is going to take some time, and that some time is nothing but that particular period of the, so you have to design in such a way that so you can deal with, if suppose your requirement of, suppose for this amount of time, suppose it should remain at that particular position. Okay, let's consider like that. So in that particular case, you already know, suppose what is the angular velocity, etc. Okay, so those, or you can play with that angular velocity also, that is there, but provided if you already know this angular velocity and you cannot change the angular velocity, then like you can play with this particular angle. Okay, so that is the strategy. So later on we'll discuss how we actually do those things. Okay, so up to this much I hope it's clear. So next type of cam is cylindrical cam. So now this in cylindrical cam, what's happen? The follower, it reciprocates or it can oscillate also in a direction which is parallel to the cam axis. Okay, now you can see. So as we have said, the cams may be of different shapes. So in that particular case, the cam axis is this one. Okay, this is the cam axis. Okay, and about this axis the cam is rotating. Okay, and now generally in the cylindrical cams there is kind of groups cut. Okay, some depending on what kind of motion you need. Okay, some groups are being made on that particular surface of the cylindrical surface of this particular cam itself, and there it is, this follower is actually contacted there. Okay, and whenever it is rotating, whenever the cam is rotating, depending on what is the contour of that particular groove, so what will happen, so there will be some positive displacement on this particular follower. Okay, so now you can see in this follower, this portion of the follower, the whole thing is follower. So here it is attached like this. Okay, and these are the guides that is provided. Okay, and because of this particular guide, so this particular follower is only constrained, it is constrained to move along this direction only, it can reciprocate along this direction. So it is a kind of constraint movement, it cannot go somewhere else, but depending on what is the contour. So if the profile is something like this, let's consider the profile has been cut something like this, then from this extremity to this extremity, once again this side. Okay, depending on whatever is the contour. Okay, it will it will move. Okay, because it is something like as if it is being jammed here, and along with this it is also getting a particular motion. Okay, and this motion is transmitted to this particular person. Okay, so then really as here you can see there will be always some motion. Okay, so whenever it has got certain motion here on this particular cam, due to this particular arrangement there will always be some motion on this particular follower, and that's why these cylindrical cams are also known as positive drive. Okay, similar is the case depending on how you're actually constructing it, so it can be oscillating kind of motion also. If you pivot this particular portion here, if you make a pin jointed here, then whenever this is rotating, this cam is rotating along with that already here in this particular group it is attached here. Okay, so now what will happen, it will be constrained to oscillate only, it will, the movement will be oscillating kind of movement only about this particular point. So this is about cylindrical. So there is another kind of cam known, we call it as like a N cam. So here the N surface of that particular cam is the actually working surface. Okay, so sometimes it is included within the cylindrical cam itself in some book. So now it is somewhat similar to the, just like whatever we have discussed cylindrical cam, but here what happens, the difference is the follower makes contact at the periphery of the cam. So previously you have seen here itself the contour was made. Okay, and the follower was attached here. Okay, contact was here along with this. Okay, and after that whatever is the constant we provide here. Okay, based on that either it is going to oscillate or it is going to get the reciprocating motion. in the previous case. Now you can see here the shape of the peripheral shape of this particular cam has, it has, we have made the contour, okay, on the periphery of it. Now if we cut something like this, okay, let's consider the person and this periphery is being cut like this, okay. Now we are giving certain contour here, and the follower is attached here on this particular periphery of that particular cam. Then what will happen if this is rotating, just like in this case, okay, if this is rotating, so the different portion, okay, this different portion will come in contact, this called different portion of the contour. Now whenever this portion comes in contact, as it is rotating, so all those, these portions will come, okay. So sometimes, so what will happen, this portion will come, okay, come here, okay, and in this particular portion time it will fall, okay. So this way, this here end cam is operating. We can also have weights and flat cam. So the name itself suggests what is this, what is weights cam, what is flat cam. So here for weights cam, the cam is of weight shape, as you can see in this cases. Okay, weight shape cam. Okay, and here it is constantly, you can say constant slope is there, so it will be continuous kind of motion. Okay, continuously it will move up, continuously move down. Okay, similarly here we can also have different contour cut. Okay, so apart from that, here we are showing this is a spring loaded as well as this is a reciprocating type of follower. Okay, and here it has been pivoted here, and because of this pivoting, okay, what will happen whenever this, depending on what is the contact surface, what is the level of the contact surface, whether this is the contact or here we have got a contact or where we have got the contact. So this particular follower will get up and down motion, and along with that, what will happen as this bar is pivoted here at this particular location, so this will reciprocate or oscillate, not reciprocate, sorry. So similar is the case like for the other cases. Okay, similarly we can have flat faces, okay, flat cam with a group, etc, etc. So now so here also we achieve positive drive without using spring in case of flat cam with groove. So for the other cases we are using spring loading. Okay, so in the case with flat cam with groove, just like the case of cylindrical cam, okay, if in the groove we press the follower, then we get a positive drive without even using the groove. Okay, and this cam has translational motion in both the cases of wedge as well as flat cam. So similarly, we can have spiral cam. So here the spiral books are being cut. Okay, in the form of spiral that is being cut. Okay, and generally kind of here the follower arrangement is somewhat different. So here you can see the spiral groove. It consists of certain teeth, and this teeth it meshes with a pin gear follower. Okay, so basically this is a pin gear follower. So here meshing is there. Okay, meshing of this. And apart from that, we have got conjugate came, globoidal came, spherical came, etc. So those things are for you. Those are the self-study. Okay. Up to this much, I hope that's clear. Yes or no? Let me know.
Yes, sir.
Okay. Others?
Yes,
Sir.
sir.
Sure.
Yes. Yes. Okay. So next type of you can say came classification is based on follower movement. That means what kind of motion the follower is getting from that particular cam. Okay, so based on that also we can classify the cam and follower pair. So based on that we have got actually so by this time all of you already know that. So we are having kind of sometimes follower goes depending on that particular what is the profile of that particular cam. Okay, we have seen the, if we think of that particular reciprocating, the basic radial cam with a reciprocating follower. So in that particular case we have seen that basically there is position or there is time when the follower is moving up, right? So similarly, we have also seen there is position when we have called that as the dual period, when there is motion on that particular cam, but the follower is not getting any motion. And the reason was basically it was encountering the constant radius curve. okay, on that particular follower portion. Okay, so there may be, that means there may be some dual also. Okay, similarly, so initially if it has moved up, and after that suppose for some time it is remaining there in the up position itself, okay, without having any motion to the follower, so we call that as a kind of dual period. Okay, so the dual may be in the very beginning, in mid, or in the end of the stroke also, that is different. Okay, so it will depend on what is the, from where actually, what is the profile of that particular cam. Apart from that, from where, which position the cam stroke has started, so it will depend on that also. So now in that particular case we have seen some follower displacement. Initially, like it can go up. Okay, okay, that means positively upward movement or rise kind of stroke. That particular stroke we call as the rise stroke. Okay, so it would maybe there, or we call also as out stroke. Okay, that means follower is going out or it is moving up, that is rise stroke. These are called as strokes. Okay, next we have seen, can have, there may be another possibility, it can be, it can have the dual period or the dual stroke, where there is motion on that particular cam is supposed rotating. Okay, but the follower is not getting any motion. Not getting any motion means the follower is remaining stationary wherever it was. Okay, and during that time cam is moving, because and cam is moving from one location to another. Okay, but that particular portion is something like constant radius curvature, that particular portion only it is moving, that's why there is no motion that the follower is getting. So that is known as the dual. And similarly, after that, the follower may go down depending on, because we are thinking of a complete revolution, which is 360-degree rotation of a, or a complete revolution we are talking about. So within that particular revolution itself, this kind of things might happen. Okay, the follower may go up, known as the rise stroke or out stroke. The follower may remain wherever it was. It may be in the upward position, okay, in the down position also, but wherever it was, it will remain there. Okay, there will not be any motion the follower will get. Okay, that is the dual stroke. And from the up position to the down position, once again follower will go down. Okay, that is known as the return stroke. Okay, so these are the basic strokes. So now the cam classification based on follower movements are being done based on that only, what kind of stroke is there. Okay, so first one is like we can have RRR type of cam. That is, it stands for rise, return, rise, RRR. So what happens here? That means from the name, from this type itself, we'll understand what kind of follower movement, what kind of movement the follower is getting. So here we are saying that RRR, rise, return, rise. That means initially the follower is going up, then it is going down, once again it is going up, and that kind of situation, if you think of a complete revolution, this kind of thing is happening, and after that it will be the same motion will be repeated. That's why if we can understand about the motion of that particular whatever is the motion that the follower is getting within a complete revolution, okay, 360-degree angle, within that, if we can analyze the situation, then after that it will be just repetitive kind of thing. Okay, so now there is one diagram that we draw. Okay, so that is known as the displacement diagram for this cabin follower, where what we show along the x-axis, we basically show the cam angle or the cam angular movement, that is the theta, and we draw it for one complete rotation. Basically, that is one complete rotation means the 360-degree that we are talking about. Okay, one rotation of the cam. Okay, this is the cam angle, or cam rotation angle theta we show along the x-axis, and in the y-axis we show the follower displacement. So that means during that motion of this particular cam, okay, what kind of, what kind of motion the follower is getting. Okay, how it is getting displaced. If this is going up, then we'll say that some positive displacement will get. After that, suppose may go down or something like that. Okay, so now first type is rise, return, rise, R. So that means here you can say the cam is constantly rotating. That means we are showing this side. Okay, theta. Okay, this side positive follower displacement. Okay, so first stroke is we are talking about rise stroke. That is just going up. So this is rise. Then suddenly we are saying about we have got after that return stroke. Okay, and that is going down. So this is the rise R type. Okay, next we can have like dual rise, return, dual D. Okay, so sometimes what may happen, so the stroke, the working of the cam, it may start from the dual itself. That means the cam has started rotating, but it is there during that time there is no motion on this particular follower. Okay, that is known as the dual. So now if we start from the dual rise return dual DRRT. So if we start from the dual, that means there is no follower displacement. If we are starting from zero, then during that time follower has not got any displacement. Okay, so it will remain here. But the cam has already, let's consider this is the theta, okay, or theta 1, okay, this much portion cam angle cam has already rotated, okay, but there is no motion, no displacement here on the followers. Okay, so this is 12. So after that this is rise, okay, rise positive displacement that is there, return means going down, and after that there is another, that means for another time, okay, so there will be some motion on this particular cam within that particular stroke, but there is no motion on this particular follower. Okay, so that is it. Similarly, we can have DRD. That means dual rise, dual return, once again dual. So starting with dual, and there is rise stroke. So as you can see here, okay, starting with dual, there is cam angle has rotated by this much angle. Okay, cam has rotated by this much angle, but there is no motion on the follower, no displacement. Okay, next the rise stroke. Next, after that, once again, it has raised up to this much displacement. Okay, the displacement has occurred on the follower. Now, once again, there is dual. So, as I have already said, dual means just during that time cam is rotating, but there is no motion that you get on the particular follower. Okay, so wherever follower was, it will remain stationary there. It's not like it has to be at this particular bottom location, but wherever it is encountering dual, from there is no motion. So as already it has rise up to this much, so in this particular dual it will remain here, and this is the, if you think in terms of the angle, so this much will be the dual angle, and we know it is cam is rotating with a certain angular velocity, so to rotate by this much angle, it is going to take certain time, okay, certain time t, and that time is known as the dual time. Okay, so this kind of, as we are saying, this is the displacement diagram, we call it this as displacement diagram. So this kind of displacement diagram of cam and follower can also be drawn considering the time along x-axis and follower displacement along y-axis, because if we know about this angle and all, okay, then if we talk in terms of the time also, okay, how much time it takes, then also we'll be able to know about the angle, how much angle it has done during that particular time. Okay, but in general you consider the theta here, but if you in terms of t also we can discuss, because for rotating this first angle a certain time it will take at a certain angular velocity. Okay, similarly we can have dual rise dual, like just like this particular case here, after this much this is dual, okay, then there is rise, okay, then there is once again dual, and the complete operation is done. After that suddenly it is falling down, this is known as the fall. We don't use the word return here in this kind of cases, this is a kind of hypothetical kind of thing, so this kind of situation actually should not be there, sudden fall should not be there, it should always be somewhat smooth curve. Okay, that is what is generally expected. Similarly, cam classification based on follower constraint, we can have preloaded spring cam where the constraint contact is ensured by some compression spring, preloaded compression spring. We can also have positive drive cam. Okay, here the constant touch between the cam and follower is maintained by roller or follower operating in the group of a cam. Already we have seen. Okay, similarly, gravity cam also might be there where the rise is achieved by the rising surface of the cam, and rises because of the whatever is the rising surface of the cam design is there, because of that the follower will rise. Okay, and return is by the force of gravity, because the follower will have certain weight and it always wants to go down. Okay, so now along with the whenever the follower is or cam is rotating down, okay, during that time due to the gravity itself, force of gravity itself, the follower also will go down, that is the return stroke will be accomplished due to gravity. So this way also we can accomplish. Similarly, forward, if you want to classify, then also it can be classified based on shape, what kind of movement it is getting, and where is the location of the line of movement. So based on shape, like we can have already we have discussed all those things. Okay, knife edge follower. So you can see. So it is based on the shape of the point of contact with the cam surface. So knife edge follower, you can see here. Okay, so look is something like this, but it has got some limited use because of this particular knife edge. Okay, actually some plowing kind of phenomenon might happen, and heavy wear on the surface it might be there. Similar is the case for like we can also have roller follower. Generally, it's a widely used cylindrical roller for it to rotate about a pin joint. This is the pin joint. Okay, you can see in the roller. Okay, but if we think of a very steep rise that is there, then the roller floor jumps the cap. Okay, so for steep rise and all, roller floor is not prepared. So we can also have like mushroom floor. Under that, we can have flat face floor and spherical floor. Okay, generally they don't have the problem of jamming. Okay, but high surface stresses and wear is there due to deflection and some misalignment that might be there. Okay, so for that actually we use the spherical face follower where some of this problem of the might be reduced. Okay, similarly according to movement, all those things already we have discussed somewhere. Okay, so we can call it like reciprocating type or oscillating type. As you can see here, the follower is getting reciprocating motion. Here it is pivoted about this particular pin, so getting reciprocating motion. Okay, similarly depending on the location of the line of movement, so as we have already discussed, radial or inline type, where you can see the cam line of movement of the follower. This line of movement is here, or axis of rotation of the follower. Okay, it passes to the center of rotation of the cam. Okay, so this is the radial or inline type. So if that is not happening, okay, if this is suppose axis of rotation is along this direction and this is the center, okay, and there is certain eccentricity between them. Okay, so if this is the situation, then they are known as the eccentric follower or offset type follower or cam and follower and so on. Okay, so with this, we'll stop here for today. So in the next class, we'll start with the basic nomenclature for camp profile. That means what are the different words that we use for designating the different arms that is there the camp profile. Okay, and after that, we'll see about different motion of it, and after that, we'll discuss about how to design the camp profile. Okay, so some numericals, that thing will solve. Okay, so with this, we'll stop here for today. If you have any question, you can ask.
No, sir.
Others?
No, sir.
No.
Okay,
No,
okay,
sir.
then we'll stop here. So respond to your name calls. Nilutpal,
Present, sir.
Shankar,
Present, sir.
Asman,
Present, sir.
Rehan,
Present, sir.
Rehan, Partha,
Present, sir.
Rishikesh.
Hello.
Partha is present?
Sir,
Present,
Rehan
sir.
present, sir.
Yeah, Rehan is given. Partha, what about Partha?
Present, sir.
Okay. Rishikesh, Basumatari,
Present, sir.
Hermiki,
Present, sir.
Mahasol,
Present, sir.
Teja,
Present, sir.
Rishikesh Nath, Rishikesh Nath, absent, and Emil.
Yes, sir.
Okay. So Emil, you are not sometimes you are present, sometimes you are absent. So try to be regular. Okay. Okay. So with this, we'll stop here for today. Thank you everyone for joining.
Thank you, sir.
Thank you, sir.